Hello, my name is Gabriel and I work at the Advanced Controls Research Laboratory at the University of Illinois. As the name suggests, we focus on controlling systems and our research varies wildly. All of this, however, boils down to a simple idea. We model and analyze a system and then design some logic to make it follow our commands. Usually, these systems are some form of a robot, and today I'm going to explain the basics behind controlling one with ever-increasing popularity, the quadcopter or drone. A quadcopter is nothing but 4 propellers attached to motors held together by a frame shaped like an X. Here, the quadcopter is resting. The only 2 forces acting upon it are its weight and the ground's reaction force. Since they cancel each other out, the quadcopter will just sit there. As the motors spin up, the props generate thrust. Once the thrust is greater than the quadcopter's weight, a net force appears in the upper direction, creating an upward acceleration. We're now flying. If we wish to stop at a certain altitude, we simply generate an acceleration downward by decreasing the thrust and then equaling it to the weight again to hover in place. Now that we're hovering, we're in a state which control engineers call an unstable equilibrium. That's because, in a perfect world with a perfectly built aircraft and no external disturbances, the quad would hover nicely. This, however, is not the case. Imbalance in the props, imperfections in assembly, winds, and many other phenomena will tilt the vehicle in some direction. When that happens, a net force appears in the horizontal plane and the quadcopter starts drifting. To counteract that, we measure this tilt using sensors much like the ones in your smartphone and command one motor to generate more thrust than the others, moving it back to the original angle. And if we wish to move horizontally, we simply generate this tilt ourselves and move it where we want. To swivel around, things get a little more interesting. The same way a helicopter has a tail rotor to stop it from spiraling out of control, quadcopters have a way of controlling yaw. 2 motors spin clockwise and 2 spin counterclockwise. Due to the law of the conservation of angular momentum, if we wish to spin clockwise, we accelerate the counterclockwise motors and decelerate the other 2. The inverse applies for spinning the aircraft in the counterclockwise direction. Okay, now let's fly. Here, we're going to take off, then perform a figure 8 flight pattern. First, all motors spin up, generate thrust, which creates a force upward. The aircraft then takes off and hovers. Much like the animation before, here we see the forces acting upon the aircraft. Now, we tilt the aircraft to move forward. To start turning, we tilt it sideways to generate the centripetal force. At the same time, we yaw counterclockwise to maintain the force pointing towards the center of the turn. The rest of the pattern follows the same way. These are the basics of how we fly a quadcopter. The really hard part is how we command each motor to generate those forces and make it follow some desired path. That's where research in controls comes in. I hope this video sparked some interest in how drones fly, and better yet, interest in pursuing research in controls.